pendulum. Now, tunapozungumzia simple pendulum, kuna vitu ambavyo ni vya msingi hapo uvijue. Length unapima, ambapo nitakuelekeza namna ambavyo unapima. Halafu utahesabu time for 10 oscillations. Sasa 10 oscillations ili upate period. Kama kwa mfano umepata labda tuseme 15 seconds. Ili nipate oscillate period ambayo ndo time, nachukua ile 15 na gawanya kwa number of oscillations. Kwa 15 divided by 10 is equal to 1.5. Hii ndio inaitwa period, 1.5. Kama nimepata 14 seconds, baada ya kuhesabu 10 oscillations, maana yake ni kwamba nagawanya kwa 10, napata 1.4 seconds. Kwa hiyo inakuwa period. Now period is obtained after you have taken the time that you have got for 10 oscillations divided by the number of oscillations. If now you're talking about 20 oscillations, maana tunagawanya kwa ngapi? Kwa 20. Kama unazungumzia 30 oscillations, unagawanya kwa 30 oscillations. Kwa kama nimepata labda 13 seconds, then I should divide it by 10 so that I get 1.3 seconds. Kwa hiyo inakuwa period. Kwa ile ya kwanza inaitwa time for number of oscillations. Then nyingine inaitwa period time, na hii hapa inakuwa ina written small letter t, alafu hapa inakuwa written capital letter T. Sasa kumensha hapa, kupima sasa. Kwa mfano tunaambiwa the length of 100 cm. Maana yake ni rula nzima. Si ndio? Kwa hiyo ukiangalia hapa hivi, hapa ndipo tunapoanzia. Sasa kwa nini tunafunga hii hapa hivi? Kwanza ili kuifanya kamba yetu iwe tight vizuri. Kwa sababu kama tungeifunga hapa, I don't think it would be tight in a good way. Kwa tunaifunga hivi. Sasa sisi tunaambiwa tupime sentimita 100, 100 cm. Sasa hatuwezi tukapima kuanzia hapa. Tunapima kuanzia hapa mpaka pale ambapo halfway ya pendulum bob, ambapo sasa tunapima 100 namna hii. Sasa tunaiongeza kamba yetu mpaka ifike 100. Kwa here is 100. Mnaona? Sio hapa mwisho wa kamba. Hapa katikati ya pendulum bob 100. Sasa this is the length from here up to here is 100 cm. Sasa kama ndio hivyo 100 cm nimepata, mimi nashikilia stopwatch yangu. Naivuta. Sio kwamba sasa navuta mpaka huku. Hata kama nimekaza, sasa navuta mpaka huku naanza hivi. Sio lazima. Japokuwa ni kwamba ile nani itakuwa ni ile ile. Lakini unavuta tu kaengo kadogo. Simple line. Haka tu kadogo tu, unajaribu kuvuta tu kaengo, kisha unaachia. To and flow, one oscillation. To and flow, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unaacha. You don't need to stop this one. Hautaki kuizuia hii hapa. Unaizuia iende wapi? Wewe unachotakiwa ni kustop ni nini? Ni stopwatch. Huyu acha aendelee. Hata kwenda mbinguni wewe acha aendelee. Then wewe una record data zako. You have to be very careful. You got my point? Yes. Kwa hiyo usihakikisha haichezi hivi. Na usivutie huku kwa sababu ukivutia huku itagota kwenye meza. Kwa unavutia, hakikisha hapa iko straight namna hii. Hii inaitwa at equilibrium level, reference level. Kwa sasa una adjust angle as you need. Lakini hakikisha vile vile hapa hii string imejikaza. Usije ukavuta ikiwa hivi, alafu kafanya hivi. Unaona inatikisika. Ile kamba inapofanya vibration, that is error. Kamba iwe tight. Then unavuta. Na sio lazima uachie hapa ndo uanze. Unaweza ukaiacha ikaenda, ikarudi hapa ndo ukaanza. Now you adjust a certain angle. Then like here, then you leave it. Sawa? Then you can start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unanielewa vizuri? Yes. Kisha unapunguza tena, unapunguza kadri unapopunguza lensi ndio inapoenda haraka. This was a length of 100. What if a length is 50? Now this is the length of 50 centimeter. Kwa ukiangalia, ukivuta, unavuta tu kidogo. Naona? Kwa hiyo imeanza kwenda haraka. Kwa unaweza ukaiacha kaja hapa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You stop your watch. Then utaona as you decrease your length. Let's talk about 20. Now what if the length is equal to 20 centimeter? Kamekuwa kadogo, una stretch. Just simple like. Mona 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Umemaliza. Hata akija mwingine hapa akaanza tena, utakuta anapata result the same. Hata ukisema this is 10 now, I'm talking about 10. Hivyo una stretch kidogo, unaachia 1. Unaona? Kanakuwa kanaenda faster. Yaani engo ni ile. Kwa hiyo utaangalia kwamba hapa naanzia wapi sasa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kwa what is important, lazima uhakikishe kwamba umenote. For the length this one, yaani ile movement ya kwamba to and fro, 1 oscillation. To and fro, 2, 3, 4. Yaani kanapoenda hivyo, ndivyo unavyo balance. Sasa ukihesabu 1, 2, 2. That is not a reality. Oscillation is the movement of a pendulum bob to and fro. That is called 1 oscillation. Sasa, what if tayari umepata data? It was to complete the table, and then the graph is between t squared versus L. You have to know the nature of your graph. For the t squared versus L, from t is equal now to 2 pi, then L over T under it. Manake, I have to make sure that t squared versus L are there. This is y, this is the x. Palipo na x naweka nini? L. Palipo na y naweka nini? T squared. Ambapo by squaring both sides, then you have t squared is equal to 4 pi squared L over G. Maanake nimeondoa under root kwa kusquare hapa na kwa kusquare hapa. Sasa if that is the case, mimi lengo langu where there is x, mimi na put L. Sasa na rearrange tu hapa equation inakuwa ni t squared is equal now to 4 pi squared over G times what? L. Tayari hapa this is y is equal to mx. Sasa hii hapa yote ina represent as so far x is equal to L. Kwa hiyo hapa yote ina represent slope. Kwa hiyo the slope is equal now to 4 pi squared over G. It is now where I can determine the value of G. Sasa simepata slope, then G is equal now to 4 pi squared over slope. Kwa hiyo mimi nikisha determine slope ya equation ya graph yangu, ndio itakayonipa G. Kwa sababu 4 is constant, then pi is equal to 3.14. Where there is pi, I put this one. Then the slope zimepata kwenye graph. There's nothing I can do. Then what is the nature of the graph? Nature of the graph, then t squared intercept. T squared intercept from t squared is equal now to 4 pi squared over G times L. If now L is equal to 0, t squared intercept is obtained when L is equal to 0. Now t squared also is equal to 0. Kwa hiyo kwenye y intercept itapita kwenye 0,0. What if L intercept is obtained when t squared is equal to 0? Nikiweka t squared is equal to 0 hapa, nitaenda L is equal to 0. Kwa kwenye x itapita kwenye 0,0. Now the nature of the graph is this one. Sasa since slope yetu ni positive, kwa maana hiyo equation yetu itaonekana, graph yetu itaonekana namna hii. Kwa hapa ndipo utakapopata. Kwa hapa itakuwa ni change in t squared over change in L. Here there is t squared, here there is L in centimeter. Kwa wakati naenda kuchora, mimi najua kwamba nature of my graph itapita hapa na itakuwa iko hivi kwa sababu ya positive gradient. Hata kama akibadilisha atakwambia bana, tubadilishe basi tuseme kitu kingine tofauti. What if now the graph is L versus t squared? From t squared is equal to 2 pi, I mean t is equal to pi L over G. Manake, you make this as y and this is as x. That is the principle behind it. Hapa kitakachokuwa kiko tofauti ni ile graph, lakini the value of G itakuwa ni ile constant. Now, hapa itakuwa manake from t you square both sides. The t squared is equal to 4, now pi squared. Kwa nini 4? 2 squared is equal to 4. Then A over G. You have to make L as the subject of the formula. Then you have to multiply by G over 4 pi squared. By G over 4 pi squared. Then this cancel this one, this cancel this one. Utabakiwa na L is equal now to G t squared over 4 pi squared. Sasa mimi kwenye x ndo kuna t squared. Kwa hiyo itakuwa sasa L is equal now to G over 4 pi squared times t squared. This is x and this is y. This is m. Therefore, the slope now, kwa hiyo utajikuta sasa kwamba slope is equal now to G over 4 pi squared. Kwa G is equal now, closing multiplication. Hapa itakuwa slope times 4 pi squared. Kwa kifupi T is equal now to 4 pi squared times m, but m is called the slope. Lakini pale tumeona ili tupate g itakuwa ni 4 pi squared over slope. Sasa kama mwanafunzi amekariri hajaelewa, atajikuta yeye anachanganya mafaili na matokeo yake atajikuta g ni tofauti. Na net of the graph itakuwa ni hiyo hiyo, kwamba yote itapita kwenye original. Na kumbuka hapa ni positive, kwa hiyo lazima itapita hivi. Lakini ikitokea negative utaiona. What if the slope is negative? Ambao kwenye umeme sasa masuala ya electromotive force inatuhusu sana. Na mara nyingi unaikuta kabisa inakuwa inabadilika kabisa ile graph. Ilikuwa imekaa hivi inakuja inabadilika hivi. So what is important is to know the nature of the graph. Ukifeli kuelewa nature of the graph, hapa jamani mimi nawaambiaga kila siku, hakuna mwanafunzi ambaye akielekezwa kushika vifaa anashindwa kuhesabu. Shida, the problem is how to use the data that you have obtained. Umepata data, unazitumiaje? Hapo ndipo panaanzia tatizo. Physics is something very simple. Kwa mimi hapa unafikiri kuna mtu chora soma, mimi nasoma tu. Soma hiyo. Mimi nimeingiliza naanza kusoma. Ni kitendo cha kusema to and fro. 1 2 3 4 5 6 7 8 9 10 na stopisha stopwatch yangu. Na reading. It's all about reading. Sasa shida ni kuconclude. Data hizo unazitumiaje? Na hapo ndipo mimi huwa napenda kuskiki na wanafunzi. How to use the data. Ukishajua kutumia data, maana yake you can even represent what you have done in your experiments. Starting measuring the length, you have to consider your pendulum bob. This is a pendulum bob. Ile distance ya length ambayo una consider lazima ije ifike katikati ya pendulum bob. Unaanzia katikati ya pendulum bob au unaishia katikati ya pendulum bob kupandisha sasa huku. Now if I may use this one, this is how I measure the length. Now we have length of 100 centimeter. The length of 100 centimeter, it is definitely you mark. You put your mark, kunaweka alama by using a mark pen or using anything that will put data. This is my point of 100. Then you hang. These are the boxes that you may use for tightening your loop. Now this is my table value. It is from here now. The length of 100 centimeter, 880 centimeter, 60 centimeter, 40 centimeter, and 20 centimeter. Now time for 10 oscillation. For 10 oscillation, when the length is 100, time for 10 oscillation is what? Then we have period time, that is capital letter T. We have small letter t for time for 10 oscillations, time taken for the number of oscillations. Then we have period, that is what we call it period time, that is capital letter T. And this is obtained while taking the time that you have located here, or you have indicated from here. It is done simply because we want definitely something from here. Example, now you have get 15 seconds from here. Then you divide by the number of oscillation so as you may get what we call it period time, that is T, capital letter T. Then we have T squared. Now T squared, the square of this time that we have got, period time that we have got it here, after we have divided by the number of oscillations. Now the number of oscillation, the time that is obtained from here, divided by the number of oscillation, it is where now you can find the time, period time, that is capital letter T. Now let us start for 100 centimeter. Now this is my stopwatch. Now for the length of 100 centimeter, let me adjust it at a certain angle. Certain angle. Then this. I may start. haina maana ya kwamba mpaka sasa nianze nayo. Naweza nikaivuta hivi alafu then nikaiachia. Haitaki kucheza cheza. Naweza nikaivuta hivi kwa inaenda. Kwa naweza nikaamua sasa kuanzia popote pale niende nayo. Sio lazima ninapoanza na hasa nianze. Naweza nikaamua tu kwamba I may start from even if now it is started. Now this is what. Now let me relax. One, two, three, 4, 5, 6, 7, 8, 9, 10. Now this is 20. The time that I've got, it is 20 exactly. The time that I've observed here, it is the time, the movement. Now I can even start it again. It is 20. Now for 100 centimeter, the time is 20 seconds. It is 20 seconds. That 20 seconds for 10 oscillations. When the length was 100, now when the length is 100, the time for 10 oscillation is equal now to 20 seconds. How about the time for 80 centimeter? Now let me start it again so as to make sure that if it is true, let me verify it. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is the same applied. It is in 19.84, which is equal to 20. Now the time for 10 oscillation when the length is 100 centimeter is 20 seconds. Now we have 20 seconds as the time for 10 oscillation when the length is 100 centimeter. What if the length is 80 centimeter? 80 centimeter. Centimeter. It is definitely here. Now I've already measured the 80 centimeter. Now let me tighten it here. Now let us see for the length is equal to 80 centimeter. Means from the pendulum bob to where the string is suspended, the length is equal to 80 centimeter. Now let us see. This is it. You adjust at a certain angle, then you rev it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it is 17.8. Let's do it again for the second time. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same applies to 17.82. Now, the time for 10 oscillation when the length is 8 centimeter, it is 17.82. Now let us see what if the length is 60 centimeter. What if the length now is 60 centimeter? Measure it from here, 60 centimeter. Here it is. Now you put your mark. Then you tighten. So when tightening it, you have to make sure that this is my box. My length starts from here. That is how. If that is my thing, my length starts from here. Not here or here. It starts from here. Then ends at the mid of the pendulum bob. Now this now for the length of 60 centimeter. What if the length is 60 centimeter? You tighten it here. Let us see if the length now is equal to 60. That means the length from the mid of the pendulum bob up to where the point of suspension. The point of suspension, it is now we measure the length of 60 centimeter. Now what if, let us see, you adjust your pendulum bob like this one, then you leave it. You can see. Then you can start anywhere. When oscillating, you can start it anywhere. As for your wish. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I've got 15.03. It is 15.03. Let me do it for the second time. It is 15.3. Sorry, there was some sort of error. Let us do for 60 centimeter. Now this is the way I do it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. To the same applies, it is 15.32. Now we have 15.3. Then let us do for the other case. When the length is 40. For 40 we can even measure it from here. Length is equal to 40. To measure it from here, somehow complicated. Let us see. What if now the length, what if the length is 40 centimeter? Let us see. Now, you adjust a certain angle. A certain angle, that is. So you can decide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 12.35. Let us do it again, 12.35. Let us see if it is also the same thing. 12.3. Now it is 12.0. Now let us start it again to see. What if the length is 40 centimeters? Let us see. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same applied, it is 12.22. We can do several times as we wish. Now we have 12. For the first time we had 12.32. Now for the second time we have 12.22. Now we have 12.23. Let us do it again to see if now we manage to do it in the proper way. This is the way we do it. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same applied, it is 12.34. So now we have 12.3. Then let us see if the length is equal to 20 centimeters. What if the length is equal to 20 centimeters? Now this is how we measure. Now what if the length is 20 centimeters? Let us see. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 80.97. 8.97, you record somewhere, you do it again. It is 8.97. Let us do it again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is the same applied, 8.88. We can try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same applied, it is 8.91. Now in short, when you find the average, you find it is 8.9. It is 8.9. So we are through about recording the time for number of oscillations. Now let us see how we can determine the period time. That is what I've said. The time taken for the 10 oscillation divided by time oscillation, that is time, period time, and then time. Let us see how we can fill our table of values. That is in short what I've said. This is the table of results. Now, time for 100 centimeter, it was time for 10 oscillation, it was 20.0 exactly. And time for 80 centimeter, the length 17.8. And time for 60, it was 15.3. And time for 40 length, this one, 12.3. and 20 it was 0.08.9. Now, we said in order to get the period, we take the time from here, we divide by the number of oscillation. We were told that time for 10 oscillation, that is 20 divided by 10, that is 2.0. If now we may approximate this one, now we get this is 18. This is now 18. It is what? 18. If now we may approximate this is 15. If now we may approximate this is 12. Then this is 9. You got it clear? Now, if now we divide by this one, we get it is 1.8. Because in order to get this period, lazima tugawanye kwa kuchukua muda wa number of oscillation divide by number of oscillation. Kama tumeambiwa time for 20 oscillations, maana yake tunachukua zile time ambayo tumepata for 20 oscillation, we divide it by 20. Then here it was 15, then it is 1.5. Divide here by 10, it is 1.2. Divide here by 10, it is now 8, it is now 0.89. That is 0.9. Hii ndio inaitwa time, period time. Now, inapomove to and fro, inateki seconds ngapi? To and fro inachukua sekunde ngapi? Kwenye 100 centimeter, to and fro 2 seconds. Kwenye 8 centimeter, to and fro 1.8 second. Hiyo ndio tunaita period time, and it is represented by time by t, capital letter T. Sasa tukitaka t squared means 2 times 2, that is 4.0. Now 1.8, that is 3.24. Then this one, it is 2.25. This is the 1.44. This is the 0.81. If now I may approximate, this is the 4 exactly 0.0, this is 3.2, this is 2.3, this is 1.4, this is 0.8. This is what I have. Have I made myself clear? Because the graph is between. The graph is the t squared versus what? Length. Ambapo tulionesha mathematically namna gani tunaipata. Sasa if that is the graph, sasa tunaenda kuplot. We are plotting, this is length on the x axis. And this now is t squared on the y axis. This is y and this is x. If now that is the case, now let us plot. Very simple. Now let us see. Now the graph, the title of the graph is the graph of t squared, the second squared, against the length, that is in centimeter. Then underline. Then you plot x and y axis. Because if now you remember, we said our graph itapita kwenye nini? It will pass through the origin. Kwa maana hiyo hatuna haja ya kufikiri sasa tutaiwekaje. Si tunatwanga tu hapa hivi. Let us twanga in here. You have to be very careful. Please, I beg of you. Very careful. about this. Then here it is. Now this is now we may light our scale here. Our scale here. We have vertical scale, we have horizontal scale. 1 centimeter will represent 1 centimeter will represent. Don't say equal. Imeshasema mara nyingi usiseme equal. Will represent. Sasa our scale here, ukiangalia, this is the horizontal. This is plotted to horizontal. Here, let's say this is in centimeter. Length in centimeter. This is the x-axis. Then this is y-axis. Then it is t squared, s second squared. We want to know lenses. Our lens here, you can see, it is 20 to 100. Now, may it fit here? If you look at it, you find it, how many centimeters are there? 15. It is 14 centimeter. If now it is 14 centimeter, if now we talk about 5 by 14, it is less than 100. Now, let us move by 10. Now, here it is 10. Here it is 30. Here it is 50. Then 70. Then 90. Then 110. Then 130. Ukiona hapa, nimeruka moja moja kwa sababu nataka tukifanya graph yangu iwe neat. Haina maana kwamba this is a limit and you have to do it this way. No, please. This is not a principle. Then, for horizontal scale, 1 centimeter will represent 10 centimeter. I'm done for horizontal scale. Vertical scale, as you can see, my results, it is 0.8 up to 4.0. But if now you may see the length of your graph up to here, it is 20, approximately as 20. Now you may think 20, we have 4 as maximum. Now you take that 4 divided by 20. Which now is equal now by 4, 1 by 4, here it is 5. It is 1 over 5 now, which is equal to 0.2. Now my graph ranges to 0.2. It is not supposed to be less than 0.2. If now becomes 0.2, that is a problem. But now let me use 0.25. Here 0.25. Then here it is 0.5. 0.275. Then here it is 1.0. Then it is 1.5. Then it is 2.0. Then here it is 2.5. Then here it is 3.0. Then here it is 3.5. Then here it is 4.0. Then here it is 4.5. Then here it is 5. Sasa ukiangalia hapa, when you look at this one, 1 centimeter is 0.25. Here it is 0.5. It is not a principle that I must start with 0.5. Lakini mimi nimetengeneza tu neatness of my work. Now, means 1 centimeter represents 0.25 second squared. 0.25 second squared. Now, this is my scale. This is my scale. I am through about the scale. Now, I have to represent my results on the graph. Remember, 20 by 0.8. Sasa hapa mwe makini sana kwenye kurepresent. Zitawachanganya kweli kweli, but not a problem. 20, when length is 20, definitely here. This is 20. But now, t squared was 0.8. 0.5 is here. But here now is 1.0. But here, between 0.5 and 1.0, it is 0.75. Kwa hiyo hapa hivi, hii ni 0.75. Sasa mimi nataka 0.8. Sasa usije ukalogo uka approximate ukasema hiyo 0.78 uki approximate naleta 0.8. Kwa hiyo mimi nina 0.75. This is what I have. Don't approximate and make it 0.8. Don't approximate. Natakiwa hapa ni 0.05. Sasa kwa sababu kwenye vertical scale tumesema sentimita moja, 1 centimeter is equivalent to 0.25. Sasa hii ni sentimita moja. Sasa milimita moja, kale kamoja kana ngapi? Kwa maana hiyo ni 0.25 divided by 10. Kwa sababu 1 centimeter is equal to 10 millimeter. Kwa maana hiyo sasa kumbe hapa nina 0.75, halafu kila kamoja kanaongeza 0.025. Kwa sababu 0.25 divided by 10 it is 0.025. Kwa kamoja ni 0.025. Sasa mimi nataka ifike 0. Kwa nitaongeza vingapi hapa ili viniletee 0.8. Kwa maana hiyo hapa nahitaji 0.05 ili nifikishe ngapi? 0.8. Kwa maana hiyo hapa nazidisha, vitaongezeka viwili ambapo ni 0, then 5, then 0, 0. Kwa vikiongezeka viwili itakuwa ni 0.05 ambao nikijumlisha itakuwa ni 10, then 8, then 0. Kwa nitapata exact 0.8 kwa kuongeza vimilimita vingapi? Viwili. Kwa vimilimita viwili vile ukichengesha tu kidogo hautapata straight line. Kwa maana hiyo nitaongeza kumbe viwili. Sasa kama hapa natoka hapa ni 20 na nili yangu inasema ni 20 by 0.8. Kwa 20 ni hapa. 0.75 ni hapa. Kwa nitaongeza viwili ambapo sasa nitaongeza viwili itakuwa hapa. Kwa haiko kwenye huu mstari, haipo. Imepanda juu kidogo kwa sababu nimeongeza vimilimita vingapi? Viwili. So that is what I've done. Then we have 40 by 1.4. 40 by 1.4. 40 is right here. So this is 30, this is 50. Here it is 40. By 1.4. 1.5 ni here hapa. Sasa this is 1.5. Sasa mimi nimepata 1.5. Nahitaji nipate 1.4. Maana yake natakiwa nipunguze 0.1 hapa. Sasa kama kila milimita moja ina 0.025. Ili nipate 0.1 natakiwa viwe vingapi? Vinatakiwa viwe vinne. Ambapo sasa italetea 0.1. Kwa maana kutoka kwenye 1.5 natakiwa nipunguze vimilimita vinne ili nipate sasa ile 1.4. Kwa naenda kwenye graph yangu ambapo it is 40 by 1.4. 40 is right here. Yenyewe haina shida kwa sababu definitely inapatikana. Then napanda mpaka kwenye 1.5 hapa. Hii 1.5 hapa. Kwa kutoka kwenye 1.5 napunguza vimilimita vinne. Kwa hiyo ni 1 2 3 4 itakuwa hapa. Sasa maana yake nimepunguza vinne. Kwa kama nimepunguza vinne, I am exact at my point. Then nyingine ni kwamba it is 60 versus 2.3. 60 no problem. It is definitely here. When length is equal to 60, but time is equal to 2.3 t squared. Now this is 2.0, but here it is 2.25 because our scale is 0.25. Kwa hapa itakuwa ni halfway ambayo itakuwa ni 2.25. Sasa don't make 2.25. Usije ukasema 2.25. Sasa na approximate napata ngapi? 2.3. Hauwezi ukafanya hivyo. Kwa hiyo unaongeza vingapi? Kwa sababu hapa natakiwa niongeze 0.05 ili iwe ngapi? 2.3. Sasa maana yake natakiwa niongeze milimita ngapi? 2 kutoka kwenye 2.25. Now when it is 60, 2.3. 60 here, 2.3. 2.3. Naongeza milimita 2. Halafu then we have the other 83.2. 83.2. 8 is here. 3.2. 3.2. This is here. 3.0. Now this is 3.25. Sasa hapa ni 3.25. Anatakiwa niondoe ile 0.05 iondoke. 0.05 tumesema unaondoa vingapi? Viwili. Kwa hiyo kumbe kwenye 3.25 napunguza viwili, ambapo sasa napunguza mimi viwili kutoka hapa. Kwa hiyo itakuwa exactly 1 2. Kwa utaona graph yangu inaendelea kupanda. Then that was 80. Then we have 100 versus 4. 100 definitely here. 4 exactly ipo yenyewe. Kwa tunapanda na 100 mpaka kwenye 4. Here it is. Yenyewe exactly iko hapa. Now let us join our points. But remember, the nature of the graph will pass at its original. Your nature of the graph. Kwa tunaanza kujoin. Kwa you make sure that it is at the origin. You may see. Hii sio lazima point zote zije kwenye original. At least 3 points. Angalau ziwe point ngapi? 3. Kwa sababu ukisema moja au mbili ziwe kwenye straight line zipite kwenye original, hakuna itakayofeli. Yaani mbili lazima ziwe kwenye straight line. Hata kama nyingine imekaa hivi, nyingine lazima utanyoosha tu zitakutana. At least 3 points. Now this is the way we join it. Utaona imepita kwenye original bila hata shida. Now let us find our slope from the graph. Ngoja tuseme tena tufanye likubwa kabisa. Nani hao wanajua kuna mwana bwana? Tuwasikiza mna adabu kweli. Mbona kugombana na watoto wasikiza kila mara. Adabu hamna. Now this is the change in T squared, and this is the change in L. So now we may note our points. From here, this is how we do it, and from here we have this one. Now here it is 20, but here it is 100. Then this point we may note from here. Here was equal to what? 0.8. Then also here was equal to 4. Now from the graph, we are looking for the slope. We are looking for the Slope. Which now is equal to change in t squared over change in L. Yeah. But remember, from the graph, we have seen T1 squared is equal now to 0.8 second squared. And T2 squared is equal now to 4.0 second squared. Then length 1 is equal to 20 and length 2 is equal to 100. All this centimeter. Kwa sasa hizi tumezipata kutoka kwenye graph. Graph yetu ni hii. This is our graph. Ambao kama mnavyoiona iko very straight na tumeshachagua point zetu ni hizi hapa. Kwamba this is L2, this is L1. This is T1 squared and this is T2 squared. Kwa kutumia hapa tuna move hivi, tuna move up. This is change of T squared, this is change in L. Now we have T1 squared. Now let us see how to do it. Slope is equal now to change in T squared over change in length. Which means T squared, T2 squared minus T1 squared over L2 minus L1. But from the graph you have seen, T2 is equal to T2 squared is equal now to 4.0 seconds squared. And then T1 squared is equal now to 0.8 seconds squared. And then we have seen the length 2 is equal to 100 centimeter. And the first raise, that's L1, is equal now to 20 centimeter. But we are looking for the slope. Now the slope is equal now to T2 squared, that is 4, minus T1, 0.8. This is second squared. This is the second squared over length 2, that is 100 minus 20. All of these are called centimeter. Now the difference between this and this one is now it is 3.2 seconds squared over the difference between 100 and 20 is 80 centimeter. But now, if now we take this one divided by this one, it is all now we get 0.04 seconds squared per centimeter. That is why slope now is equal now to 0.04 seconds squared per centimeter. Now we have got the slope. After we have got the slope, now definitely what we are looking for, from we've been given T squared versus length. Now from the equation, T is equal to 2 pi, then it is L over G under roots. Let us make this as the subject of this formula. Now we square both sides. We square both sides. Then we have T squared is equal now to 4 pi squared L over G. Then we have to rearrange so as to make sure that here there is the X, this is the X and this is Y. Because when T squared versus L, this is the Y and this is the X. Now we have to rearrange. Now T squared is equal now to 4 pi squared over G times L. Now this will meet our condition that this is for Y and this is for M and this is for X. Now this is for X and this is our slope. Now our slope now is equal now to 4 pi squared over G. But now we are determining the value of G. Now G is equal now to 4 pi squared over slope. But remember now, if now our gravity is equal now to 4 pi squared over slope. But remember, pi is a constant which is equal to 3.14. And then slope is what we've been given, which now is equal to 0.04 seconds squared per centimeter. This is what we've been given. Now let us substitute this one because what we are looking for is for the value of G. Now by substituting we have G is equal now to 4 times pi is equal to 3.14 times 3.14 over it is 0.04 second squared per centimeter. Mathematically, by 4 here it's 1, by 4 here it is 0.01. This is what we are looking for, the value of G. Now G will be equal to 3.14 times 3.14 over 0.01. But this is centimeter per centimeter, it is second squared per centimeter. It will check then become centimeter per second squared. Now after dividing this one, we have to multiply, is equal now to 9.8596 centimeter per second squared over 0.01. In order to remove the decimal, now we have to multiply by 100 both times. Now G will be equal to 985.96 centimeter per second squared. But remember, the value of G is meter per second squared. Now we may even convert this one by converting 1 meter is equal to 100 centimeter. Now how about 985.96 centimeter is equal to what? It is where now we can divide by this one. Now we say our G will be equal now to 9.8596 meter per second squared. Now if now we may approximate, the value of G is equal now to 9.86 meter per second. Why now this one? Now this is how we can determine the value of G. Determining the value of G, it is because from the slope, 4 pi squared over G is equal now to slope. Now this slope is obtained from the graph. After we have got it from the graph, we use this slope in order to get the value of G. It is where now we say G is equal to 4 pi squared over the slope. But the slope is something that we have got it from here, we have to substitute it from here. Now if now we substitute it to this equation, we definitely find that G is equal to 4 pi squared over slope. Now which the slope is this one. Now at the end of our calculation, the value of G is equal to 9.86 meter per second squared. We have got 985.96 centimeter per second squared, but the SI unit of G is meter per second squared or Newton per kilogram. But what we are about to show is meter per second squared. And that is, we know the relationship between meter and centimeter is that 1 meter is equal to 100 centimeter. That is how we do. Now by closing multiplication, it is where now we get 9.8596 meter per second squared. Which now, when we come to approximation principle, we have 9.86 meter per second squared. Now this is how we determine the value of G experimentally. Tunavyofanya. Kwa cha msingi hapa ambacho nimewambia ni represent graph. Yaani zile data unaweza ukawa nazo tu, lakini mwisho wa siku huwezi ukamaliza. This is a very important thing. Thank you very much for watching. Now you keep on subscribing.